Okay, Algebra 1. We are going to do two more optional examples. These will be really good to go through if you're still feeling a little bit confused. And again, these are all on your notes, and I also have my copy of them uploaded to the page as well. So we are going to look at two examples, one where they give you factored form, and we have to figure out standard form from the graph and from factored form. All right. And one where they do not give you either equation, they just give you a graph, and we've got to figure out what the equations are. All right. So let's take a look at these two examples. I'm going to zoom in a little bit so we can see them a little bit better. All right. On this graph, we can see our key features. We can see two roots, two zeros. One is at 2, 0. So I'm going to label that 2, 0. All right, and another one over here at -3, 0. I can also see my that is my x-intercept. I can also see my y-intercept right here at 0, 6. All right, I can see that it's concave down. I can also see my vertex. It's at -0.5 and then a little higher than 6. All right. And so we've got lots of different things here that can help us identify things for these equations. Now I can see that these two x-intercepts, all right, they come from these two factors because -3 plus 3 will give you 0 and 2 minus 2 will give you 0. I can also tell that this negative right here, this negative a value tells me I'm going to be concave down, all right? So I'm going to kind of highlight that and show myself that this negative a is going to be concave down. All right. So knowing this, I can tell a few things about standard form. All right. I know my a value is going to be negative, so I'm going to put a negative out here. And I also know what my c value is. Remember, standard form is ax squared plus bx plus c. That last portion, that constant term, is going to be my y-intercept. So I know I'm going to have a +6 out here. But I'm not sure what the rest of this is going to be. So we can figure it out by multiplying this together. All right, so we've got some connections so far. My connections are that this c value is my y-intercept. My x-intercepts I can see in factored form. Now let's go ahead and do the multiplication. So I'm going to multiply the two factors together first. These two binomials, because there's two terms. Bi means 2. So 1, 2, there's 2 terms here. 1, 2, 2 terms here. So it's a 2 by 2 area model. I put x plus 3 on top and x minus 2 on bottom, and now I'm going to multiply. X times x gives me x squared. 3 times x gives me 3x. X times -2 gives me -2x. -2 times 3 gives me -6. Now, when I look in this area model, I look for like terms. I have two terms that have the same variable with the same exponent, and that's this term and this term. So when I add all these up, these two can be combined. All right, this one can't because that one has a squared. These ones don't have a squared. So when I write this out, I'm going to start with x squared. And then when I add those together, 3 minus 2 gives me 1x left. So I'm going to write plus 1x. You don't have to write the 1 if you don't want to. And then minus 6. But I can't forget that factored form also had this -1 here. So I'm going to distribute in a negative to all 3 terms. All right, I'm going to multiply this in here, here, and here. Another way to think about this is just change the sign of each term. So negative times x squared gives me -x squared. All right, a negative times a positive 1x gives me -x. And then a negative times a negative gives me +6. So we have factored form, standard form. These are equivalent. They both show me this graph, but standard form shows me the y-intercept, and factored form shows me the x-intercepts. They can both show me that it's concave down because they both have that negative a value that tells me that both of these ends are going to go down. Let's do one more example. All right, this one was a little trickier. This one doesn't give me anything. It didn't give me factored form, didn't give me standard form. It just gave me a graph. All right, so let's take a look. On this graph, I see some key features. I like to identify those I'm going to label. Okay, I'm going to start by labeling my zeros, my roots, my x-intercepts. So right here I have 2, 0, and over here I have -4, 0. Now I'm going to go to my y-axis. When I take a look at that y-axis, it goes 5, 6, 7, 8. So this one right here is 0, 8. There's my y-intercept. Now I can also show my vertex and my axis of symmetry. My axis of symmetry is going to be right down this middle. All right, axis of symmetry is right here. That's at x equals -1. All right, I can also see that the vertex is right here at -1, 9. But I can't see my axis of symmetry or my vertex in either of these equations. There's a third form of the equation called vertex form. That's how you could see that, but we're not learning about that quite yet, okay? So I know a couple things. Oh, and I also know that this is concave down. I'm gonna add that on my list over here. We've got it concave down. All right, so since it's concave down, what do we know about the a value? Is it going to be positive or is it going to be negative? It's going to be negative. So I'm going to put a negative out here and a negative out here because I know my a value is going to be negative if it's concave down. All right, that's the first thing I know. Now, I know this y-intercept is 8. So I'm going to put a +8 at the end of this because my c value has to be 8 for standard form. Now, the rest of standard form, I'm not quite sure about yet. For factored form, all right, I remember factored form. I've got things being multiplied. So I've got multiplication. So I'm going to draw those parentheses for multiplication. And if my x-intercept is at -4, what is my factor then going to be? X what? All right, it's going to be +4 because -4 + 4 gives you 0. Let's try another one. This root is 2. If this root is 2, what is the factor going to be? X - 2. Perfect. All righty. This is very, very nice. So I also know we've got this x squared here, but I'm not quite sure what goes in here. So to figure this out, we're going to use our area model and do some multiplication. So let's take a look. All right, so I'm going to take that x + 4, and I'm going to put it here. I'm going to take that x - 2 and put it here, and we're going to multiply. X times x gives me x squared. X times 4 gives me 4x. X times -2 gives me -2x. 4 times -2 gives me -8. I look for like terms. I've got some like terms, 4x and -2x. All together, this is going to be x squared, all right, plus 2x minus 8. Now I'm almost done. If I look at this, it doesn't look equivalent to this because look, that's negative and that's positive. This is positive and that's negative. So I can't forget about that negative that I'm going to distribute. So I'm going to put it on the outside and I'm going to distribute it to all 3 terms. Negative times x squared gives me -x squared. Negative times positive 2 gives me -2x. Negative times a negative gives me positive 8. Whoops, didn't need that. So this is the last thing we needed for our standard form, -2x. So now, given a graph, you can take that graph and turn it into standard form, turn it into factored form. If you're feeling confident, you can pause. That's great. I'm going to show you guys one more method. So instead of this area model, some people like to use something called double distribution, which is something called FOIL. So I wanted to show you that real quick. You don't have to watch it if you don't like to. But if you're feeling like, I'm not sure I like that method, I would like to know another one, then I can show you one more before you head out for this week. So FOIL, this FOIL stands for, it is an acronym. So F stands for first, O stands for outside, I stands for inside, and L stands for last. So FOIL is one way that you can multiply a binomial times a binomial. Now, my preference is that I like to use this area model because it keeps my work organized, and it works for if I have a monomial times a trinomial, or if I'm doing any sort of fancy multiplication, I can always use this. This only works for 2 terms times 2 terms, but some people really like it, so I'm going to show it to you, all right? So what this means is that you multiply, so first means that you take the first term of this and you multiply it times the first term of this. So first times first, x times x gives you x squared, okay? So that's first. So I'm just gonna color code this so you can see. First is this part. I'm gonna go in a rainbow order here. Next is outside, all right? Next is outside. So I take the 2 outside terms and I multiply them. The outside terms are going to be this one and this one, the ones that are on the outside. So these 2 are first, but the outside would be this times this. All right, x times -2. So that'd be -2x. All right, next is going to be inside. So you guessed it, you go to the 2 terms that are on the inside and you multiply these 2. So you get 4 times x, which is plus 4x. And then finally, we do our last terms. So we take the last one of this factor and the last one of that factor, and we multiply. 4 times -2, which gives me -8. Now, if you notice, what we got here is the same exact thing as what we got here. All right? Same exact thing. Here's that. Here's this. Here's this. Here's this. Same exact thing. You just have to remember to match up every single term. You have to multiply every single one. And then we can combine like terms. These 2 can be combined and you end up with the same thing. So if you like this better, you can use it. I recommend this because it keeps your work nice and organized and you can use it in more than one situation. It's a tool that's more powerful, but both work perfectly fine. All right. If you have any questions, go ahead and make sure you reach out to your Algebra 1 teachers. It was nice seeing you guys this week. Bye.